Hey, what's up guys? My name is the Cherno. Welcome back to my game engine series. For the first time now being streamed live on Twitch. Link will be in the description below if you want to catch future live streams. So last time we talked about the whole camera system. In fact, our whole journey so far has been with the entity component system, and we talked about camera systems and how we can integrate cameras into our scenes and all of that fun stuff. Check out that video if you haven't already. And today we're going to be continuing on a little bit with our camera system because there are a few things that it just does not support yet, such as resizing the viewport. So without further ado, let's dive on into our code and take a look at what it is that we're going to be doing today. So the main problem that we have here, if I just give this a quick build, is when we resize the viewport, it just doesn't really like resize the camera. So in other words, this little square that we have here gets really squishy. And in fact, if I bring that back, you can see, did my lights just turn off? Thank you, wife, for turning off my lights on stream while recording a video. All right, go. Go. Classic wife. I was talking about this square being squishy. So if we resize this, obviously the square gets squishy. Our goal for today is to make it so that the square does not get squishy, because we ultimately want to resize the aspect ratio of the camera if that happens. So the way that we need to do that, it's like, in general, this whole problem is pretty simple. But you know, us making this game engine series, usually we want to talk about the problem in a broader sense, as well as talk about all the possible implications of this problem. And this is going to be a perfect excuse for us to actually jump in and take a look at, how should cameras get resize events? Should all cameras in the whole scene get resized? What about the whole editor versus runtime camera situation? There are so many things that we could discuss. And in fact, about half an hour before even starting this episode, I spent the last half hour discussing this with Twitch chat and planning this in general. So definitely a good discussion and definitely a lot to be said, but I'm going to now try and condense this into this episode. So ultimately, what we kind of came up with is there are two types of cameras that we have in our scene. This is not counting the whole editor camera or, anything like that. During a game's runtime, there are ultimately, you could divide cameras into two different categories. The cameras that essentially should be rendering some kind of view of the scene that is directly tied to a final kind of render output to our viewport or to our actual screen. So in other words, if I make a 1920 by 1080 game window and I'm playing my game there, I want my camera to fill the screen. If I minimize this, or rather, I guess not minimize, but make the window smaller and maybe change the size of the window, I want the window to basically be my viewport into this either 2D or 3D scene that is kind of a viewport into my game world. That obviously should be tied with the size of the window or your viewport or your render area. The other type of camera that we have, though, is something that doesn't necessarily need to be tied to the current viewport size. So a good example is, maybe I have like a TV in my game that's obviously always going to be like a 4:3 aspect ratio. It's like an old school like TV somewhere in the corner, and it's displaying an image which happens to be a live render of a different part of the scene. That's always going to be 4:3. I don't need to worry about the aspect ratio there because it has nothing to do with the size of my game window. As would, for example, a shadow map. If you were rendering like a shadow map through a camera, which is an entity in your scene, for some reason, then you might decide that that's fixed. It's always going to be a 1024 by 1024 shadow map, so therefore a 1:1 aspect ratio. That's not something that needs to actually be changed if I resize my window. So in other words, we have two categories here. We have the kind of fixed aspect ratio category, and then we have the not fixed aspect ratio category. And the non-fixed aspect ratio category is where all of our kind of, I guess, well, not all of our, but our main camera, that's the category that it falls into. So what we're going to do is basically into camera component, we're going to add a new boolean, and it's going to be called, let me just zoom in for you guys. It's going to be called fixed aspect ratio equals false, okay, by default. So what that means is if you set fixed aspect ratio to true, and this will be like a checkbox that you can actually check in the editor when you're designing your game, then that means that the aspect ratio is fixed, meaning it's not going to care if the main viewport that you're rendering to gets changed. Whereas if that is set to false, then you would expect the camera's projection matrix to actually be updated. So with that in mind, we should now be able to, inside editor layer, this is going to be the next step. Editor layer has, inside the onUpdate function, it has camera controller on resize, and well, you can see that this is kind of the resize area. If the viewport size has changed, and it's now like it's, you know, whatever, we resize the frame buffer, obviously. We also want to say that, hey, active scene, let's set the viewport size to be something else, right? So you could set the viewport size here, and I think I probably will do that. But I'm actually going to rename this and call it on viewport resize, and we're going to chuck in this code here. And these are, what are these? These are floats technically, but I think I will just make this a uint 32t. All right, so we have inside scene, we now have a function. Wow, scene is looking empty. On viewport resize, uint 32 width, uint 32 height. Let's create an implementation for that. So I want to set viewport width and height here. So the reason I want to do this is because they might be useful later, so I just want to keep track of them. But to be honest, I don't know if we'll need that anytime soon. So we'll initialize them to 0 in case we never get that event. Viewport height equals 0. And then here we want to resize our non-fixed aspect ratio cameras. So how do we do that? This is really easy. We just need to basically create a view. This is called, there were some errors. Some people pointed out some errors with what I wrote, which is to be expected. I don't think there are really any errors here. I think I just accidentally called this group, even though it's a view. Do I have any other errors? I don't think so. All right, so we basically need to do the same thing. This actually is a group, I think. We basically need to do the same thing, whereas we're just using one component here. So instead of doing like multiple components here, we're going to just do the camera components. So we have a view into all of the camera components in the scene. And now that we've done that, we can do view.get camera components dot camera maybe. And this will be our camera. What did I do here? Registry view, entity view. Oh, right, we need the entity. Okay, so we'll get the camera here, and then we can now see if the camera has a fixed. Oh wait, sorry. This is what we want. This is the camera component. So if the camera component has a fixed aspect ratio, right? If it doesn't, well, if it does, then whatever. If it doesn't, that's where we actually need to resize it. How do we resize it though? This is where it gets a little bit tricky, and this is kind of the next phase of this video. So what do we need to change a camera's aspect ratio? Well, realistically, the way that you probably want to do this is to recalculate the projection matrix. And to recalculate the projection matrix, you need to know how to make that projection matrix. So what is all of the source data that went into making that projection matrix? So in other words, if we take a look at the way that we made this in the first place, which to be honest, I don't remember. It looks like we just created an orthographic matrix here, actually. We said -16, blah, blah, blah. We need this same data here to try and figure out how exactly to do this. Now, realistically, this data that we're looking at, -16, 16, -9, was very, very arbitrary. It was something I just made up because I'm like, okay, well, let's just pump in a matrix. It's not really how we want to do things. Instead, what we want to do is create a little bit more flexibility and robustness by saying that what we should do for an orthographic camera is just specify a size. I mean, especially if it's fixed aspect ratio, we really just should have a size. So how big is this orthographic camera? Like, are we dealing with like -10 to 10, -100 to 100, -1 to 1? You know, what is the size of this orthographic camera? And usually, well, I don't want to say usually because people do this differently, but we could say, for example, and I think the way that I'm doing this inside Hazel Dev actually is I'm basically just saying that the width is going to be the orthographic size times that aspect ratio. So in other words, when we talk about an orthographic camera size, we're talking about the vertical field of view, I guess. Field of view is probably not the right term to use because it's not a perspective projection camera. It's an orthographic camera. That's why we kind of say size instead of field of view, because it's not a frustum. But that's going to be our vertical, just the same way as FOV is usually vertical FOV when we're dealing with like graphics programming. So because of that, the height is going to be our orthographic size, and then the width is going to be our orthographic size times whatever the aspect ratio is. So for a 16:9 aspect ratio, which is 1.78, we would have a FOV, sorry, not a FOV, we would have a width of 10 times, well, if our viewport size was 10, you know what, viewport size times 1.78. So in other words, if it was 10, we'd have a like a viewport, I guess, width of, and again, you probably want to also, because it goes from left to right and also top to bottom. It's not like it's a, you know, we have to kind of deal with half extents here. So you probably have to multiply by 0.5 and then subtract one side and then add the other side. Anyway, we'll get into this in a minute. I don't know why I'm explaining this by waving my hands. I should probably be programming. But anyway, we ultimately would have like an orthographic width of about 17.8 and an orthographic height of 10. So that's the calculation that I'm thinking of doing here. How are we going to do this? Well, we could extend camera a little bit. But what I want to do, because if you think about it, this camera is inside the renderer folder, right? It's clearly something that has to do with the renderer itself. It's not some kind of like, you know, entity component system, like level editor camera class. It's actually like to do with the renderer. So as far as the renderer is concerned, I don't care about your orthographic projection. Just give me a matrix. So I don't want to modify this class and add all of that stuff. Instead, what I want to do is to the scene class, I want to add a new class. And this is going to be our scene camera. And a scene camera is going to include Hazel renderer camera. And it's going to basically derive from that camera class. So it's going to include that matrix that we have there. Scene camera, again, you know, we probably don't need to worry too much about this stuff. In fact, I probably don't even need to have a virtual destructor. No, I'm kidding, I should. Okay, so we'll add that in. What this is going to be is just it's going to be a derived version of the scene camera, which is going to have a lot of convenience functions, as well as storing the parameters that we use to make up our camera. So in the future, we're obviously going to support multiple cameras. We're going to support an orthographic camera as well as a perspective projection camera. This is what will have the type of camera set in here. And this is what we're going to show in the kind of inspector panel, I guess, when we select the camera entity so that we can see the camera component. When we're actually drawing the UI for the camera component, that's where we can obviously select if we want like a perspective or an orthographic projection, what that orthographic size is, what the perspective FOV is, stuff like that. So this class is almost a representation of exactly what we will see in that UI. So as such, we need to store that stuff. So we're not going to worry about like supporting both orthographic and perspective at this point. But what I will have is I'll have an orthographic size, which by default will be 10. And then I'll have an orthographic near. I'm just calling everything like with orthographic here, just so that it's clear what's perspective later on. So orthographic near and orthographic far, which will be +1. Okay, that's basically what makes up, and I guess just to keep this a little bit neater, I might put that on one line. This is what makes up our orthographic camera. If we have this, we should be able to reconstruct the camera. And that's what we'll be able to do. So by creating a scene camera, do I want some constructor arguments? Maybe. But honestly, what I'm going to do is just write a function here called setOrthographic, which is going to take in an orthographic size, a near clip, and a far clip. Far clip. And then what this is going to do, let me just add a CPP file. What this is going to do is, apart from actually storing this in the member variables, it's also going to recalculate that projection matrix. So that was a disaster. Let's include HZPCH as well as, sorry, I zoomed out again. I always do that. Scene camera. Let's quickly use Visual Assist here to create all of these. Yeah, we don't need this. Equals default. Let's get rid of that. Not even sure if we really need this. We'll see. Obviously, it depends here. And why is this so upset? No default constructor is for camera. Okay, that's fine. So we do need to set a projection matrix to begin with. Is that something I even want to deal with though? I'm not sure I do. I think that what we should do potentially, and I'm not exactly sure how. Okay, let's do this. Let's inside this camera class, let's add a default constructor. So it's possible to create a camera without a matrix now, but we will make sure that we will actually like set this to be a GLM map4 that's initialized to an identity matrix if that's the case. That way we can create a scene camera without anything, and then you would expect to call like setOrthographic on it, and setOrthographic, this is kind of the thing that's actually going to do orthographic size equals size, near orthographic near equals near clip, and then orthographic far equals far clip. I'll also add a function into scene camera called set viewport size. So uint32 width, uint32 height. So what this function is going to do is, based on whether or not this is an orthographic or a perspective camera, it's actually going to set up our matrix accordingly. So we have, and if I jump into camera, I may need to make this protected. Over here, what I'll do is I will basically just set the projection, which, maybe I should call this projection matrix, I'm not sure. We basically just want to set this to GLM ortho, and then this here will be, and I'm not sure, maybe I need to include it, but let's calculate the aspect ratio first. So aspect ratio equals width divided by height. Let's just make them floats, because otherwise that's not really going to work. It's going to do an integer division. Then let's do near and far, we know. So ortho width, we'll say. Oh no, we need ortho left. So ortho left will be 0.5 times aspect ratio times ortho size. Negative. Okay, and I think I want to write this in reverse just for clarity. Minus ortho size times aspect ratio times 0.5. Does that make sense? I think it does. And then ortho right is obviously going to be the same, but it's going to be positive. And then ortho bottom and ortho top is going to be the same without the aspect ratio. There we go. And then obviously ortho bottom should be negative. Okay, so that is our orthographic matrix calculated from a single size variable based on the aspect ratio of the viewport. So now that we have all of that, we can just simply say ortho left, ortho right, ortho bottom, ortho top, orthographic near, orthographic far. Look at that. That is meaty. So let's maybe move that here. We'll do that. Now I might need to include, I don't know if that's in like matrix transform or some weird thing. GTC matrix transform, that seems to include it. Okay, cool. So there we go. So now we have kind of a little bit of a dilemma though, because not only do we have to set orthographic, we also have to set the viewport size because it's useless without that. So this is where it's important to basically say that, okay, if you've created a scene, and a scene is obviously tied to some kind of frame buffer, you're rendering the scene to a frame buffer or to a viewport or to somewhere. If you're doing that, you need to make sure that if the scene updates, the scene cameras update. So what I'm saying is that you can call this whenever you like, but you need to make sure that you set the viewport size before you render. Now in Hazel Dev, I'm actually doing it a little bit differently. I'm actually setting this before we render. So if we have a main camera, before we start rendering from that main camera, we just update the matrix every time, no matter if there's been a resize or not. We'll do things a bit differently in this version of Hazel though. We'll say that only upon resizing will we actually update the camera matrix. And this was one of the things that Twitch chat decided. So what we'll do, but I ultimately agree. So what we'll do, and the reason I agree actually is because instead of just doing it for the main camera, which is what the Hazel Dev system is doing, if we have any number of cameras that should be tied to the viewport size, they will all be updated upon the viewport size changing, instead of us just, setting up just the main camera before we draw with it. So this is a little bit better. So what we'll do is inside scene, when we do this viewport resize thing, we ultimately need to get the camera component. We need to get the camera from the component and then call on, or rather set viewport size on that camera. Now that's not going to work at the moment because it's not a scene camera, but we will change it to be that. So set viewport size and then obviously width and height. So for all of our cameras now, this will set the viewport size accordingly and everything will work. Now you need to make sure though that whenever you add a new camera to the scene, it gets that event. So this is also slightly tricky in a way. And we'll explore this in a minute. But what we'll do is, what was I going to do? Going to go to components and then change this Hazel camera to be a scene camera. So we'll include, this is actually in here, I think. So scene camera.h. This now has a scene camera. We'll update all of this stuff. This takes in a particular projection matrix. I don't think we want that anymore because again, we shouldn't really be dealing with that. At least not yet, not at the moment. So we'll just keep it nice and simple like this. And then over here now, this should work. So technically speaking, if we run this code and we do some kind of, I don't know, something to trigger this, which I think it might get triggered immediately, then we should be rendering correctly with a default camera size here, I guess, of like 10. Right? An orthographic size of 10. The only place where this isn't going to work and where it still needs some love and some work is if we add a camera when the scene's already been resized or after the first frame or whatever, then obviously there's not going to be a viewport resize event. So obviously this is never going to get set. Our projection matrix is never going to get set. So that's also pretty bad. Now I do want to quickly check though to see, because this is the other kind of problem and I'm not even sure how this is again, every time, this is why it's nice to do it every frame before we actually render, because if we do it every frame, we can dynamically and very easily respond to the camera parameters changing. So if the ortho size is changed, or if something changes frame to frame, it's fine because we just recalculate the matrix every frame, so it will be updated to match the new values if that is the case. Obviously, in this case, we have to be a little bit more careful with how we change our camera's parameters because every time they change, we should change them. Like we need to recalculate that matrix. Now that's not that difficult to do, but what it does actually involve is making sure that we keep track of our viewport size, which again is extra stuff that you may not want to keep track of. But if we don't do this, viewport width and height, which I can just do like this, if we don't keep track of the viewports width and height right now, like this way, then we either need to make scene camera a lot more dependent on viewport and update it kind of more often or something like that. Ultimately, because, you know, if the viewport size hasn't changed, but I've changed my orthographic size, the whole matrix needs to be recalculated. So I need to get access to that aspect ratio. I guess instead of viewport width and height, we could just keep track of the current aspect ratio of the camera. That might be better just because that's a single float. Let's try doing that actually. Because that should be enough to recalculate everything. So we'll say M aspect ratio equals that, and then I'll cut these out instead of having a local variable. And then obviously when we do set orthographic, we ultimately want to recalculate that matrix. So what I'm thinking is we add a private function called recalculate projection. I don't know why I made that const. Recalculate projection, and that's going to do this. And then obviously viewport size is just going to set aspect ratio and then recalculate projection. We could check to see if they're different and only do it if they're different, but I'm not going to bother with that. Set orthographic is going to recalculate the projection as well. I don't know, like you probably want to, like you might want to have like various parameters here, such as, you know, set orthographic size, set orthographic near far. I'll leave that out now. I think this video has been going on for quite a while, so it's probably, no, it hasn't been too long. I was going to say, so it's probably time to end this, but we'll keep going a little bit more to finish this up. So what we will do now is, and of course I'm completely lost now. Yeah, so we've done all the recalculate projection stuff. So we should be able to hopefully go back to edit a layer and actually set up our camera entity to do the proper thing. So over here where we create this camera component, we give it a matrix. Is this even going to work? Because it shouldn't, right? Oh, no, there is... Is this coming from... I don't think it will work. I mean, it shouldn't work. I'm just verifying. Yeah, okay, there we go. So add camera component, it's not taking a matrix very kindly. So what we can do is we can add that camera component. I think by default, what will happen is, well, actually, let's do this. We have defaults for everything, so we can just recalculate the projection. And as long as we recalculate the projection, well, it's going to set up the matrix. So we should be just able to add a camera component, do nothing, just do that, right? And it should work. And it should also respond to the viewport size. Everything should be magical. Let's run this and see if it is magical. I'll be impressed if it is, because I feel like I've forgotten a million things. All right, here we go. Well, we see something. That's great. Does resizing work? It does. I'm very happy that it does. And if we switch cameras, well, presumably we did switch cameras, no way to tell. So let's actually try and change the, what's going on here? Let's try and change the orthographic size. In fact, you know what, since we're having such fun here, let's also, let's do this. So we'll do float get orthographic size, const return orthographic size. We'll also do a set orthographic size, float orthographic size, float size. Orthographic size equals size. Not const, obviously, and it should be void. And then we'll also do our little recalculate projection. So this is just a little thing that we can do to make this a little bit easier for us. So we'll recalculate the projection if we set the size, and we're actually making a getter and setter for that, so that we don't have to necessarily call set, you know, orthographic every time. So what we can do now is we can go into, so we've got a checkbox here, which is fine. Let's do ImGUI drag float. ImGUI drag float, we'll call this, so we'll do this for our second camera, I guess. So second camera, blah, 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 blah. Okay, so second camera, how should I do this? Maybe second camera get component dot camera, because I don't want to get that all the time. So auto camera equals the second camera, blah, blah, blah. drag float, second camera, ortho size, long label. And we'll basically say, so float ortho size equals camera get orthographic size. We'll do ortho size here. And if this changes, so we'll do if, then we will say camera.set orthographic size to ortho size. So now we should be able to control that second camera's orthographic projection size. And I'm getting excited. Okay, so we see that it has a size of 10. If we switch on to camera B and I start resizing this, oh, check that out. We can go negative, which is a bit dodgy, but you can see that I can change that orthographic size. I can flip back to camera A if I want to. And obviously, if we resize or if we do anything here, this will in fact stay the right size. Let's go back to camera B. Let's make this a bit smaller. And yeah, you can see resizing definitely works. So that is the next step in our camera system journey. Hope that you guys enjoyed this video. Let's bring back Twitch chat and this main camera. So if you did enjoy this video, please don't forget to hit the like button. If you're on Twitch, you can follow the channel. I'll leave a link in the description below to the actual Twitch stream if you guys are interested in joining that. I think the scheduling for these actual Game Engine series episodes is a little bit all over the place, but it's, you know, I do have, there's also a schedule that you can have on Twitch now. So if you go to twitch.tv/Cherno/schedule, anytime I'm streaming, usually I'll add an entry into that schedule along with like what the stream's about. So if you're interested, definitely check that out. If you want to help support the series, please don't forget to check out patreon.com/thecherno, where you will get access to a whole wide variety of amazing perks, such as access to Hazel Dev Code, where I'm currently building a little Mario style game in 3D with like 2D physics and stuff. And also live streaming that. And I think I'm gonna start live streaming that for everyone on Twitch pretty soon. So pretty exciting stuff. Don't forget to help support everything that I'm doing. Thank you all for watching, and I will see you next time. Goodbye.